Okay, so we're going to talk about PointSense Plant here. And by the way, feel free to ask your questions in the questions pane or the questions panel. We'll definitely get to them towards the end of the session. Now, just a real quick recap, and this is kind of touching back to what Scott was saying right at the end there. If you own plant, building, or heritage, you also do get the functionality of our basic and pro products. But the plant product specifically deals mainly with cataloged piping, structural steel. Also, it has tank analysis, brand new tie and point routines, things like that. So it's basically focused around industrial facilities. So the generic workflow for going from actual reality to your desired deliverables is essentially starting from a point cloud, gathering the data, using our software as sort of the middleman, and then getting those results into your design software to create your actual outputs. So that's your isometrics, your bill of materials, your orthographics, that kind of stuff. Obviously clash detection, things like that. So what is PointSense Plant? Well, you can see the giant ribbon here, and if anyone who's used the software since the beginning, this is probably about 6 times the amount of tools that we started with. But this is an intelligent piping product, and not only piping, but obviously structural as well. It's catalog driven. You have the ability to create catalogs from your specs as well as structural parts, whether it's AISC, CISC, or DIN, even custom parts after that. And as with all of our PointSense products, we work directly on the recap engine. We've actually been working on it since before that when it was PCG, but we will continue to work directly with the Autodesk engine. And every year that's been proving more and more beneficial as it gets more and more powerful. So we're going to start just by talking about the visual interface. You've seen this and the scan navigation stuff in the earlier presentation, but I do want to touch on it because it does play a large role in the plant product. One option you have is VirtuServe, and this is taken from the binary formats. In our case, the FLS file format is a great way to get this. But you can see on the bottom left of this image here, you have all of your scan positions in your scan map. And that gives you the ability to jump from scan to scan, and you can also see which way you are currently looking, so you know which direction you have to jump to get a better vantage point. As you can see here, you have accuracy better than 1/16 of an inch. Now that does depend on the density of that specific scan, but if you're dealing with 15 to 25 million points per scan, for example, then you should have 1/16 inch or better. Now this is something that we've brought to the table since 2015, and really it was the ability to read the recap file format in a different fashion than we could in 2014, so that's why we have that sort of bridge there. But 2015 and now even better in 2016, we're able to jump into that scan position directly in AutoCAD. So a lot of our users are kind of going this route because it removes having to have a separate external application like VirtuServe, and you can actually almost mimic VirtuServe directly in AutoCAD. And just like with VirtuServe, you have the ability to jump from scan to scan. You can see those spheres there. You can do it in the middle of a command whenever you need, and it does not exit out your command. So a lot of our users are going this route, and it's really nice, in my opinion, because you can verify all your results as they're happening in real time, where you can see the modeling overlay on top of the cloud data. It's a very nice verification of what you just did. The other thing that I really enjoy about this over VirtuServe is the fact that you can see which points you're physically snapping to, so it's kind of a nice feedback for the user. So before we get into the actual creation of your intelligent plant objects, I do want to touch on the fact that this is all catalog driven. Now, people who have used the software in the past already knew this, but we've added quite a bit of functionality as it pertains to the catalogs. You can see here in the screenshot, we've got our Plant 3D stuff just like we always have. We do have a generic format now, which is actually an API that we've written to encourage other products to be able to read our outputs. And you also can see here that we have the Revit MEP import. This is something that our users have been asking for a while, so we're very excited to have it. And there's also a link there for the plugin download. So if you're using the 16.5 version and you jump to the Revit MEP import, if you don't have the plugin already installed, you can just download it from there and run it. And what you'll be able to do from that point is go into your Revit mechanical template, export out whichever catalogs you wish, and then we'll find those parts for you in PointSense Plant. Now, Walk the Run is probably the part of the software that you'll spend the most amount of time in. And what it is, it's a semi-automated recognition of the parts that you have in your catalog. These are intelligent parts. You can bring in multiple specs if you wish, or you can take a large spec and kind of narrow it down or filter it before you start finding these parts in the point cloud. Now, every year we've been adding additional methods to insert these parts. You'll see this in the video, but we also are finally using saved cylinders in the background, and what you're going to get from this is a much faster detection speed. Before, in the past, we had to look ahead and try to detect these cylinders, and we still do that to a certain degree, but now with the new recap format, we actually have saved cylinders that we can access to enhance this part of the process. So after you have these fittings found in the point cloud and laid out, you then need to do apply constraints. And the reason for that essentially is our software is not perfect, the point clouds aren't perfect, and the fittings in the field aren't perfect. There's always going to be some small amount of error. And your design packages are looking for these fittings and these objects to be coplanar and coaxial. Now, we don't want the user to have to spend all this time going perfectly from weld to weld and making sure everything is perfectly coaxial on the center lines. We can do this for you. We have a number of ways to do it, just reading the data that we have, and then we also have two methods. And I want to explain just briefly the difference between the two methods because they do both have their needs. One is going to be a perfect version of the fittings for your design products. That means all of your 90s are going to be perfectly 90. Center to end lengths won't change, angles won't change, and then you're going to have the times where you need it to be where you need all your center lines to line up, but you need the fittings to actually show their true angles. That's probably most prevalent with cutback and routing elbows, and we actually have a really good way to address that as well. So let's go ahead and jump into this demonstration here, and you'll see we're using the scan navigation mode. And the reason why I recommend scan navigation instead of cropping or clipping is, one, it's much faster. Two, the visual quality of that view is going to be so much more enhanced than having to kind of orbit and zoom to get a perfect angle and then just hope that you don't accidentally snap to a bad point. But really the best part of this, we have customers now that can bring in billions of points in data, and you don't lose the visual quality, and your AutoCAD doesn't slow down. It's a very nice thing to be able to say that I can bring in all the data and my AutoCAD handles it perfectly. So you're going to see me jumping directly into this scan navigation mode. And again, you can jump from scan to scan as you're doing it, but look at this view here. There's no way that you're going to miss what you're trying to get. So now we're using this enhanced view to use Walk the Run. Previously, you would have either clipped and done this, or you would have done this out of VirtuServe. But here I'm snapping to the pipe, and we're going to actually go through all of the main features here in Walk the Run. So I'm going to show you a couple of different ways to kind of tackle this line here. But I want you to look closely on that flange there. You can toggle from front of face to back of face to hub, and all of the fittings actually have different insertion planes to toggle from. But here you can see a much faster detection because we are able to see these cylinders ahead of time. There's no Hollywood magic. This is what the software is currently able to do. So from here, we can just zoom over to this side. Now, you saw me insert the flange earlier. I did it from front of face. Here we're going to actually toggle to back of face. But instead of doing it out of the cloud, I do want to show you that you can also use VirtuServe if that's what you're comfortable doing. So I toggled the back of face as my insertion plane. I'm going to go over here to VirtuServe and just click any point on the back of face. And you see when I return back to my drawing, it has my flange where it needs to be, and then I can continue going. So it's user preference. We give you a ton of options, but it's up to you to use what you are most comfortable with. And here I use the traditional other pipe option. It works the same as it always has, probably a little bit enhanced because the resulting cylinder will extract further. Then we're actually using a manual insertion using the specified points around a circle. This right here, this is your fallback option. This is when our software can't find it. This is when maybe it's not in the data. But the important thing is you have a way to still get your work done. And then all I'm going to do here is just finish the run, and then you'll see very quickly, even taking the time to kind of switch options to make sure you see the whole repertoire of tools that we have, I was still able to get this line done very quickly and very accurately. So after that, I'm just going to turn off the cloud here, and we need to do that apply constraints. It looks good from here, but if you zoom in, you can actually see that fittings are slightly off. So there are the two strategies I talked about earlier. All you need to do is choose any object on the line. We highlight it as green, that means it's connected, and then we do apply constraints. Hardly even noticed a shift, but if you were taking this into Plane 3D, for example, you would have gotten water drops throughout the whole thing. Here you can see no water drops, no disconnects, and everything is good to go. So from there, now that we're in that middle step of that earlier slide I showed in the beginning, now we need to take it to your program, whatever you need to extract your deliverables. Now we've done quite a bit of work with exports this year. This is something that we're going to continue to do, especially with that generic option, and we're trying to entice other companies to kind of latch on to that API. But everyone here is familiar that we have the Plant 3D exports. We've actually included cutback and routing elbow support for Plant 3D. We also have the Revit MEP export, and then this is something we're extremely excited about, and you'll see it in a later portion, but we have the ability to create advanced steel objects. As was the case before, you can create your center lines, you can do your standard 3D solids. We've actually changed the center lines up a little bit, and we'll touch on that very soon, or right now. So this is the difference between what we call simple center lines. Now the simple center lines is what you had before. It's a single center line. You did have nodes placed for start and end points for all your objects, but the workflow to get into products like AutoCAD MEP, CADWorks, AutoPlan, etc., it was not that good. It was very cumbersome. Anytime there was a reduction, the user had to know that, and then he had to either break the line or just kind of take a different route. So what we've done now is we actually still place nodes for all the fittings, but then we place spheres to mark the ends of the reducers, the large ends. We also separate all of your center lines on their own layer denominated by their nominal size. So you'll have a layer that says nominal size 8-inch, nominal size 6-inch. And for example, if you're using CADWorks, the workflow I use is to use their router line feature, and you just turn on the layer going from smallest to largest. So if you have 10, 8, and 6, for example, you start on the 6, go to the 8, go to the 10, and products like CADWorks, AutoPlan, they're going to automatically place that reducer between those lines for you. So it saves you a lot of time, and then whenever you need to put in your flange valve assemblies, for example, you still have the nodes to snap to, and these programs will automatically break the lines and orient the objects correctly to run along that axis. So this is that line we had before, and in here we're just going to do the Plant 3D export, and all you need to do here is choose your exports. You can see a ton of different options here, and we do the piping and the steel at the same time now. There's the Revit MEP that we've been talking about. We're going to choose these objects, and it's going to start creating your Plant 3D fittings. Now you can keep your qubit objects on your same layer, but here I'm just going to go ahead and highlight them all and delete them, just because we don't need them anymore. But from there we have intelligent Plant 3D objects, and now it's just up to the user what you want to do with it. So you can see here I can continue my piping, go a number of different directions. Also I can generate my deliverable. So here's just a quick ISO. Just choose all the fittings, hit enter. If you have a production level template, obviously you can go that route as well. I'm just doing a quick ISO just to show you that we've successfully gone from no modeling, just point cloud data, and now we're going to something that you would actually turn in as a deliverable. So here are those objects, and you have the bill of materials, fully intelligent, dimensioned, everything like that. Now, this is something that we actually introduced in the last version, but it wasn't what we considered good enough. We've been working on it and talking back and forth to customers on what they would like to see in it. At this point, it is much more intelligent, much more intuitive, and it saves the user a ton of time if you only need tie-in points. If you do not need to model everything, there's no reason why you should have to use walk the run. So this tie-in point routine, it has all kinds of different options to actually specify that tie-in point. You can see here on that top row, you've got your 2 points along a cylindrical axis. If you just want to kind of nail a center line to constrain it to, we have multiple points around the flange OD, and we also have 3 points around any circle. Now, in my personal opinion, I think the middle option is probably the best, doing points around the flange OD, especially if you consider the fact that you may not always have a pipe going into the flange. But then in the option below that, you have the ability to toggle from front of face or back of face, and you can also toggle from just a unique offset. So maybe you can't see the flange, but it's this far away from the center to elbow. So there are other options just in case there's no way to actually see the front or back of face of that flange. If you notice below that, it's also grabbing a specific flange from the catalog, and actually it'll pull up multiple options if there are multiple options in your active set. Lastly, one of the improvements that we've added are multiple output options. You can kind of see it in the screenshot on the right-hand side. We do have the ability to label its coordinate, its roll and tilt direction as well, and then we also have the ability to create the solid object, which you can either convert to one of your plant design package objects, or you can just use that to continue your walk the run if you want to go that route. So what I did here is I just decided to fit a tie-in point at the top of 2 of these. Now you're going to see one and then it'll kind of transition into the next. I like to use VirtuServe just because if you switch to intensity gray, you get a really high level of detail even from that far away. And you can see here just any points around the flange OD. It's really easy to do. It's easy for users to duplicate. Then I can choose either front of face or back of face, and you can change this at the end as well. And all I'm doing is showing you, even from far away, if I can just barely see the back of face, that's enough. So as soon as I change it to tell it I just did back of face, I can choose the option here. Now these 2 flanges fell within a certain tolerance. It's a setting you can change. But then I was able to actually take the flange thickness and apply it to what I just chose out in the cloud. So this first option, you're going to see that it actually has the coordinate and the roll and tilt directions. Then I went ahead and did the same thing on the object on the right. And now all we need to do is convert these to whatever objects you want and then continue your design. So here I'm just using Plant 3D objects. I can get rid of the Qubit objects again because they're no longer needed. And then we're just going to route some piping in between. Now you're about to see why my job is to talk about software and not actually submit projects, because one is I have a very difficult time routing pipe, and 2 is there is no way that anybody would okay the result that you're about to see. But the reason I did it this way is because we're actually going to take this into Navisworks and do a clash detection against it. And that's exactly what I'm talking about. So all the drafting departments in the Houston area, don't hire me. So now what we're going to do here is just get rid of the flanges, because obviously those are going to clash with what we modeled them off of in the point cloud. Now we have that same example in Navisworks. I'm using the Clash Detective tool here. I have the point cloud selected on one side, the solids selected on the other side, and then we run the test. So immediately you can see the clash. You can also right-click on the model and snap back, directly back into Plant 3D, for example. Here you're going to see me just kind of group these clashes together and then obviously you can create reports and do all of that stuff as well. So it's a really nice start to finish process where everything is integrated. Now, another area that has received quite a bit of enhanced functionality is our structural steel. You saw earlier that I talked about the advanced steel export. We'll definitely get to that. But for anyone who's not familiar with this is catalog driven. All your major catalogs are included with the software. Full pattern recognition, and then we also have ways to adjust the beams after the fact. Now, the arrayed steel fit option, you're going to see this in the video. This is something that we've been missing. It's a very nice feature where you only have to construct a very small grid of the steel, and then you can either copy it, mirror it, array it, whatever you want to do with just standard AutoCAD commands. We'll then take all of those new objects that were created and fit them to the point cloud. So as far as the detection goes, you have a couple of options to enhance or just further verify that detection. You can kind of see it in that bottom left option, or that bottom left screenshot there. So this little green slice on the top of this, or in the middle of the steel, that's your profile slice. So if there's an object that is on top of it, or it's in the way that's actually obstructing that pattern, let's say it's a piece of pipe that's resting on it, you can move that left or right to get a more clear slice of that profile. Now, not only do we try to find what that piece is, we also try to organize the entire catalog in order of what we see as being most likely. So if it's not the top option, there's a very good chance it's going to be the second or the third option. Now, another thing that you're going to see in the video, and you can see it right here in the snapshot, is that we have multiple beam types where you can filter it and say, hey, this is an I-beam, this is a channel, this is an angle. From certain angles, everything's going to look similar, especially if it's further off in the distance. Maybe there's not enough data on it. Maybe just the vantage point's bad. Whatever the case is, you can physically tell the software what it is. Another place where this really comes in handy is if you have back-to-back channels versus an I-beam or a wide flange, or maybe you have back-to-back angles instead of a structural T. It's very difficult for any software product to know the difference between those, so you have the ability to override it. This is just our way of saying the world will not be taken over by robots. Now, the last thing you can do here, and you'll see this more in the video, you can't really see it in the screenshot, but you can hold down your left mouse button and actually erase noise or disruptive data from the preview. So if you've got, like I said before, if you've got a piece of pipe kind of sitting on top of the steel, you can actually erase the pipe out of the calculation and then hit the recalculate button, and it'll find a much better pattern for you. And last but not least, we do have the brand new advanced steel export. For anyone who was using the last version, I'm sure you're familiar with the SDNF export. That's a global standard that goes into numerous major structural design packages, but we also have advanced steel just as a direct export. Now, similar to the piping, we do need to have an apply constraints, and it's actually for the same reasons. The software is not going to be perfect. The point cloud is not going to be perfect, and the steel in the field will not be perfect, especially longer pieces that have sagged in the middle or something like that. So we need to have a way to construct it where your structural design package will accept the results. Now, we have a way to specify whether it's your center point that you want to match up, whether it's your top or bottom. You can actually toggle between, I guess, constraint points. And if you need to, you can actually say, okay, these two pieces, I want to go ahead and match up their top left corner with this piece's, top right corner. But, by and large, the overall workflow is to go ahead and find the piece in the field using the stuff you saw on the previous slide, and then we're going to find everything that connects within a specific tolerance. So let me go ahead and start this demonstration here. You're going to see all the stuff that I just talked about, but then you're also going to see it exported into a different design package. So I'm doing a detection on this vertical piece, and again, it's going through the entire cloud and organizing it in order. You have that green slice that lets you change it, but I had a good profile there, so I'll just continue. Then I can extend the beam here or do it later. I always like to do it here in the very beginning and then extend everything up to that later on. But then we're going to go ahead and detect these horizontal pieces. So if I wanted to, I could have filtered the beam shape. Now I can move my slice, and then here's where I'm actually erasing data that would get in the way of the detection. So now I'll just extend this out here. And from this point on, we already know what the piece is. We also keep track of your previous insert, so you can toggle back and forth. But the user's job at this point is just to click on the steel where it occurs in other places. So you can see here, didn't have to worry about connecting them up. We'll do that later, all at once. But now I can take all these parts and copy or array or mirror and just move them throughout the cloud and detect them, all at one time. So here I'll take these pieces. I just went here and did copy selection, and then I choose a base point, and then choose the similar base point at each iteration. Now, when you see that sphere, that means that our software is waiting to fit all of that to the cloud. So we're going to go ahead and go on the other side and do the same thing here. But hopefully you can see how much of a huge time saver this is, because as soon as we're done copying these to certain locations, we then just hit a button and it will find each one of those where it is in the point cloud and readjust all those objects. And it doesn't have to just be one direction. You can do a full grid horizontally, vertically, and diagonally. So here I'll just turn scan navigation off just so you can see a little bit better. Go from just a normal view. So you can see here we've got a ton of steel that we're going to fit to the cloud. And then as soon as you start the process, it'll ask you to confirm. It'll tell you, hey, we've got 28 pieces. And then really it's just kind of a waiting game. So you're going to see the progress bar on the bottom right. I went ahead and sped this up a little bit. It took 48 seconds for anyone who's counting. There's no way you can prove otherwise. So you can see all the pieces are fit. Now the only thing that we have left to do here is extend them or make them line up as far as their center lines go, because they're still off in certain regards. This is where our Apply Constraints tool comes in and has a much better interface, lets you specify an angle and a distance tolerance. Then you can see all the pieces that do fall within that tolerance line up to each other. Now there is also separate ways to see how much things were adjusted to make them line up, so anyone who needs sort of an analysis, you have that option as well. So we're going back to the export. You can see the advanced steel, you can see the SDNF, and in this case we're just going to choose these objects, and I chose to bring these into Revit in a structural template using Autodesk's advanced steel utility. So that's the SDNF file. Here's my Revit. You can see the advanced steel extension right there. We're going to do the import. I'll choose the SDNF format, and all we need to do is choose the file. And the important thing to remember here is these objects are coming in with their correct geometry, but they're also coming in with their correct intelligence. So as I choose this object here, you're going to see in the properties over here, it's a W14 by 82. That's an intelligent object. So it's not just a solid. You can do anything you need to with your structural design packages. And this is the last sort of major feature of our Plant software. I also wanted to talk about planar analysis as well, but this tool and the planar analysis actually got covered in some of the other presentations or in the previous presentation. But that tool, as it pertains to tanks, it's very nice because you can unwrap the point cloud like you saw earlier. You can also create very detailed reports in Excel, and then you can create that polyline grid that we saw in Christina's presentation. Now in that Excel report you can do volumes or volumes at specific height intervals, and you can also do around the circumference. So when you bring it into Excel, a lot of our customers are doing, at least in my experience, they're doing very short vertical increments and maybe a little bit more lenient horizontal increments. But you can get a deviation analysis on the surface, or a deformation analysis on the surface. You can also get volumetrics at every single height, and it'll give you the specific volume of just that 1/8 inch, for example, and it'll also give you a running total. And for any kind of deadwood, or any kind of objects inside the tank, whether it's structural or piping, whatever would affect that volume count, we have the ability to remove that as well. This is just a very quick example of some of the outputs. The color deformation map on the bottom right there, that's actually the surface that's been unwrapped. I always tell people it's like taking a rolled up poster and just unwrapping it on the wall. But you can read it from left to right and see if there is any noticeable deviation on that surface. So if the surface has been deformed over time or from an accident or something like that, you can see it very quickly. This is something that we added in the 15 release, but I did want to go ahead and put it there in case anyone is interested in it. But we do have the frustra conical analysis as well. It works exactly the same way, just has a different shape that it can fit, to the equipment. I know I kind of went through that stuff pretty quickly there, but I definitely appreciate everybody's time. And I'm not sure how many questions we have, but I definitely would like to get to those.